Welcome to the online course on problem solving using C. In this, we are going to learn an important concept in C program called dynamic memory allocation. So what is dynamic memory allocation? Dynamic memory allocation means allocating memory at runtime. So we all know that we can allocate the memory at runtime and compile time. So when coming to this dynamic memory allocation, so allocating memory at runtime, which means while the programming is executed. Normally when we declare variables like you can take example of int a of 5. So the memory is allocated at compile time. This is called static memory allocation. But sometimes we may not know the required size beforehand. For example, suppose a user enters the number of elements during execution. In such cases, dynamic memory allocation becomes very useful. So we'll have some important advantages in this dynamic memory allocation. So memory is allocated on the heap area instead of stack. The size of arrays can be increased or decreased as needed. Memory continues to exist even after a function finishes its execution. Functions can return pointers to dynamically allocated memory. In this, we have some differences between static and dynamic memory allocation. So let us understand the differences. So in static memory allocation, the memory size is fixed. Once you declare, it cannot be changed. For example, if we declare an array size of 10, it always remains 10. But in dynamic memory allocation, the size is decided during the program execution. We can increase or decrease the size whenever required. So static allocation is less flexible, whereas dynamic allocation is highly flexible. So in a simple terms, we can say that in a static memory allocation, we can't resize the memory. That is fixed. When coming to the dynamic memory allocation, we can change or we can decide the memory size at the time of program execution. Next. So in this, we'll have some library functions which we can also call as the dynamic memory allocation functions. Okay. So in the dynamic memory allocation, there are four types of functions: malloc function, calloc function, realloc function, and free function. Okay. So now let us discuss about malloc function. So what is this malloc function? We can say that malloc stands for memory allocation. Okay, malloc function stands for memory allocation. So which is used to allocate a single block of contiguous memory on the heap at runtime. So now discuss about this malloc. Okay. So as we know that the malloc stands for memory location and it is used to allocate a single block of contiguous memory on the heap. Syntax, we can take a pointer equal to, we can give pointer type and malloc and size of. Okay. Next. So here we can see the syntax of that malloc. Here the variable is int pointer. For that I am allocating a 4 bytes of memory. Okay, 4 bytes of memory. So now it's created one block of memory which contains of, okay, which contains of 4 bytes of size 5, total of 20 bytes of memory. So now it is created. A large 20 bytes memory block is dynamically allocated to pointer. So here in this given example program, we can see that, okay, we can see that. So first we are declaring the variable. So what is the variable here? Int pointer, int malloc of 20. So this creates space for 5 integers. Then we use a loop to assign values from 1 to 5. So then ptr of I equals to I plus 1. So next another loop prints the value. Now the output will be 1, 2, 3, 4, 5. So this example demonstrates how malloc is used to create arrays dynamically. In the next slide we can see the size of operator. You can observe there is no space between the size and of. It is a single word size of. Okay, here size of is an operator. Okay, so instead of writing fixed byte values like 20, it is better to use the size of operator. So why to use this size of operator? Because the size of the data types may vary depending on the system architecture. For example, we can take integer size may differ between system. So we use size of int. So when you're declaring size of int means this tells the compiler to calculate the size automatically. It returns the size in bytes. So the result type is size, which is an unsigned integer type. We all know that in the type data types we'll have integer type. In that integer type again we have further signed and unsigned data types. So the size of is like a unsigned integer type. Okay, so this makes program portable and safe. In the next slide, we are using this size of operator in our program. Okay, instead of writing 20, we'll write int pointer int malloc size of int 5. So this means allocate memory for 5 integers. So this is the recommended method because even if the integer size changes, the program still works correctly. So this improves code reliability and readability. Next, see in this example we can see how to declare or how to use this malloc function in pointer. Next we have next function is calloc function. Okay, so the word calloc stands for contiguous allocation. The word calloc stands for contiguous allocation. So it is also similar to malloc function, that is memory allocation. But the major difference between this malloc and calloc, so here the calloc initializes all allocated memory locations to 0. In this we can have the syntax. Okay, same pointer int. Instead of malloc, here we are writing calloc, number of elements and size of type. For example, we can take int pointer int calloc 5 comma size of int. So this allocates memory of 5 integers and initializes all values to 0. So this is very useful when default 0 values are needed. So when coming to this program, okay, so in this example we are having int pointer int calloc 5 size of int. So the array automatically contains 5 zeros 0 0 0 0 0. So no need to manually assign values. Then a loop print the values. Always check if pointer is null before proceeding. Okay, so once again I have to remind, so what is a pointer? Here pointer is nothing but which is used to store the address of another variable. Okay, next. Next we are having next function, that is free. So let us discuss about free function. So the memory allocated using malloc or calloc, that is memory allocation or contiguous allocation, is not automatically released. Okay, so if you don't want to release unused memory, it leads to memory leaks. The memory leak means occupied memory remains unreserved and unnecessarily. To avoid this, we are having free function. So the syntax of this free function is free of pointer. This releases memory back to the operating system. This is a very important programming practice. So in the given example, we can see first the memory is allocated using calloc. After that, it's performing required operations and printed their values. Then I am writing free of pointer, which means so after reserved. Okay, after reserved that memory will be free, which means removed. So this ensures efficient memory management. But we need to remember one thing, that is allocate when needed, free when finished. Next, we are having function called realloc. Okay, realloc function is used to resize a previously reallocated memory block. So the word reloc stands for reallocation. It is used to resize previously allocated memory. Suppose initially memory is allocated for 5 integers. Later we need space for 10 integers. That means here we need to increase our size. Okay. So instead of creating a new memory manually, we can use relac. So how to use the tree alloc means, so here also we have that syntax ptr int realloc ptr new size, which means, see in this example we can see in the first one, so it is created a large 20 bytes of memory block is dynamically allocated to pointer. So after that the size is changed from 20 bytes to 40 bytes dynamically. So with using this realloc function, we can change or we can increase our memory size to from one to another. So this is highly useful for dynamic arrays. In this program, we can see first memory allocated using malloc. After that, it's resized using realloc ptr 10 size of int. Again, always check the return pointer is null. If it is null, memory allocation has failed.